hope to have your attention and interest on this last topic, which is about, yes, please, which is about natural hydrogen. We have a lot said about green hydrogen on yesterday and also for on today. And today we will be talking about another kind of hydrogen. It's natural hydrogen, white hydrogen. It's less color than the green one, and we hope that it have his place also in the value chain for and join the value chain of natural hydrogen. Natural hydrogen, as known, is geologic hydrogen. So it's a gas occurring naturally in the earth, and it's importance because it's no footprint on its formation. So it's clean and renewable, and we hope that we have taken this adventure to make the researches here in Morocco as soon as possible with our partners, with ONHYM firstly, and we have taken all this process. So please, in this panel, I have the honor to moderate this panel and with our experts, our panelists. I'll start from left to right, it's just in the order, it's not for importance of fun. Stéphane AVER, here in my left, is in my left, is the CEO of HYNAT, an independent and pioneering Swiss company, active since 2015 in the research, exploration, and production of natural hydrogen and its residual gases such as helium. He is a specialist in business administration, banking, and finance. He has over 20 years of experience in creating value enhancement strategies and negotiating contracts at executive level with large multinationals in the field of high efficiency, high added value technologies. In 2006, Stéphane AVER founded Acus, of which he is the CEO, specializing in investments and innovative CO2 reduction technologies. In 2021, Stéphane AVER joined Dr. Abdelhamid Khalil as a co-founder of the African Academy for Ecological Development. I hope I didn't miss anything from your bio, Stéphane. If not, you can complete when you have the floor for the discussion. Next to him is Mr. Olivier LHOTE. Olivier LHOTE, we know it for years now. It's the director of the Natural Hydrogen Project at Storengy, an affiliate of ENGIE. He coordinates various exploration projects, particularly in Brazil and also in France, and the research subjects, particularly around the kinetics on the behavior of hydrogen and in the subsurface. He previously worked in the hydrogen business unit on storage, on surface and subsurface, and transport, gas line, pipelines, liquefaction, and hydrogen carrier molecules. Activities for projects with the hydrogen production by electrolysis powered by renewable energies. And last but not least, our geologist from National Office of Hydrocarbons and Mines, Mr. Reda Nbedi. Now he occupies the head of Precious Metals Department in the National Office of Hydrocarbons and Mines, over some 12 years experience in mineral exploration. He expertise spans on a variety of geoscientific domains, particularly in the identification, evaluation, and the development of precious strategic and critical metal projects. He joined in 2018 ONHYM team in charge of assessment of natural hydrogen potential in Morocco and managed the relationship between our partners in this activity. He participated on natural hydrogen exploration in several parts in Morocco, southern provinces, and the mesetas, and all parts we have assessed for it. So if you allow me, I will pass directly to the first intervention of our first panelist, which is Olivier LHOTE, will present Olivier is just to present the hydrogen formation, accumulation, possible volumes, cost, prices, and environmental benefits. And please give us your insights about this and overview of the main players involved in the exploration of the company in the world. Please, Olivier.
Thank you. I don't know if you have the slides. First of all, just some general information regarding the natural hydrogen. I don't know how far you are familiar with the natural hydrogen. In the next slide, I will try to explain you the previous one, please. Yes, how the natural hydrogen is, I would say, generated and perhaps accumulated in the subsurface. So the main component of it is the water, the meteoric water that you can see on the cross-section of a basin, classical basin. Water is percolating in the soil and in the, I would say, in the way back, you can find some, I would say, components like granite, which has, I would say, radioactive elements, which can split the water molecule into hydrogen. And deeper, you can also encounter in the basement of the basin some ferrous minerals, which can also react with the water molecule. It's a kind of oxidoreduction, and it's provide also hydrogen. So this tiny molecule, and with a low buoyancy, tend to move upwards then, and generally it escapes at surface. We can observe some emission at surface, either through elliptic circle that you have on the left, upper left, on the schematic view, or through faults. So that's where we identify, I would say, prospective area, prospective basin by this emission at surface. But what we are looking for is some accumulation. So it's in the middle of the graph. You can see that we hope to find some trapping mechanism with reservoir rocks, a sealing cover, and then have an accumulation in the subsurface, and that has been discovered in Mali. So it was the first time that we proved that accumulation of natural hydrogen can exist in the subsurface, and we now try to explore everywhere in the world to find analogs of this discovery. In the next slide, I will briefly give the three main characteristics of this natural hydrogen. The first one is that it's abundant. On the map, you have the dotted points where we found very high content of natural hydrogen in the gas analysis. So you can see that it's rather well widespread in the world, presence, and for sure there are some geological elements that need to find it, but it's almost everywhere. And the estimated volumes that we see, it's from 1 to 5 gigaton. So this, I would say, estimation can vary. We know that USGS is also evaluating far more this volume, but yes, it is a significant volume that we can chase. The second characteristic is the competitive cost of production that we can expect. So as you saw, we have some possible accumulation in few hundred meters. So with some wells, we will produce large volume we expect to have, like for natural gas. And this cost, given the volume that will be expected to be produced, is very low. And in terms of LCOH, we expect between 1 and 1.5 euro per kilogram. So it's very competitive. That's why it's worth to look at the potential that we can have with this natural hydrogen, because it can really unlock the hydrogen economy. And the first, I would say, the third characteristic, I would say, is the low environmental impact. So there is no CO2 associated with this natural hydrogen. So basically, the only emission are associated emission for the component needed for the production, and it gives a very, I would say, equivalent CO2 emission per kilogram of hydrogen produced. It has low impact on water resources, low impact on critical minerals. and low footprint on soil, so a lot of advantages. And if we go to the next slide, we can see that the race to explore this natural hydrogen has started. And mainly, and you see on the left side of this graph, with, I would say, small exploration company or startup, which are present almost on every continent, which were not existing a few years ago. And I think that during the past, I would say 18 years, a lot of companies are emerging to explore this natural hydrogen, especially in the US, where some of them already started to drill to prove this accumulation, and also in Australia. On the right-hand side, you see a major E&P company, which are up to now on the waiting seat. They are not really involved, even though it could be, I would say, a relay of their activities with more, I would say, environmental friendly, I would say, resources. And in the middle, you have some also E&P companies, some mining companies, some utilities, which start to explore, either for their clients or decarbonization of their activities, and which start to take some acreage or to launch some R&D project. So that's in a nutshell, I would say, the panorama of this natural hydrogen exploration.
Thank you, Olivier. Thank you. It's a good insight in the mechanism of formation of natural hydrogen. We have taken this experience now 4 years, I guess, the last decades, many similitudes, mainly with the petroleum exploration, but also taking all the advantage of our knowledge for mineral exploration. And the models here, we are challenging the model with, we have a unique model for the formation and the accumulation of natural hydrogen. And we will wait until we have a good commercial exploitation for this kind of hydrogen that we hope to develop. Now I go toward the Reda. Reda, just to give us some additional technical and economic watch on what you have learned from your experience.
Thank you. First of all, I would like to thank the organizer for holding this session, which is talking about a different type of hydrogen. It is an occasion not only to discuss, but also to inform and to promote for this kind of hydrogen, known as natural hydrogen, or also white, native, or geological hydrogen. So to answer your question, from next slide, please. So from an economic and monitoring view, as you know, the hydrogen market is expected to reach $600 billion by 2030, and forecasts are that it will reach $1.5 trillion by 2050. So it's a huge market, and sure, natural hydrogen will find itself in this huge market. C'est l'écran qui est éteint. L'écran il est éteint.
It's only for this screen, or just, but it's projected in the other screen.
So this huge market made several startups, junior and major. Yeah, several startups, junior and major, joined the race to explore for this resource. As you can see in the map, all the continents are seeing a rush for the exploration of this kind of hydrogens with companies in. So many companies, junior, majors, and startups are looking for hydrogen in the different continents, and Morocco is one of the countries that has been targeted for the natural hydrogen explorations. Also, in the last 12 months, we can see that many billionaires are are attracted by these commodities, as we see in the right of the screen, Jeff Bezos, Bill Gates, or also Fortescue managers. And despite of private investors, there is also government concern for natural hydrogens. As you can see with the US Department of Energy, who announced the funding of 16 projects with $20 million, or the French president that promised massive funding for natural hydrogen. Next slide, please. From technological monitoring, there are two approaches for natural hydrogen explorations. The first one, which is based on the flux, and the second one is based on the entrapment or accumulations. The second one is especially used by the petroleum backed company. It means that the model for exploration is based on the identification of a source, a pathway, a reservoir, and then a trap. While the second model is based on flux, and it's not a total entrapment of the hydrogen, but only the presence of buffers that lower the flow of hydrogen coming to the surface, which means that we have markers of the hydrogen seepage to the surface, known as the fairy circles, or the depression that we see in the surface in the left. So I think that both of the approach are good. The first one is can take us directly to area where we have natural hydrogen accumulating in the subsurface. But to find bigger reservoir, I think that the entrapment model is the one who can give us larger reserves, because all the natural hydrogen is entrapped under the seal. Thank you.
Okay, Rida, we just taking all the best from the models, from the just scientists in the world. They just take all their best from what exists in the petroleum or in the mining sector. But anyway, now we are moving to another aspect of natural hydrogen and the project of other hydrogen, and I'm addressing to Stéphane. Just just please, Stéphane, give us what is the most significant project worldwide, and according to your experience and your relationship with the market and with the business model. Stéphane?
Yes, thank you, Mustapha. If you are okay, if everybody is comfortable, I'm very tired, and I will switch in French.
No problem.
It
has
okay
been
for
done.
you. I can
Stéphane,
speak in English if you want.
It has been done before, and we are not the one who. Please do.
I jump
okay, please. No
plane by plane, and it's a little difficult sometimes. En fait, on fait dans l'autre sens, en fait. C'est ça. Okay, no problem. Quand Mustapha m'a demandé d'abord remercier Irezen de nous avoir invités, remercier l'organisation et remercier l'ONHYM d'être à nos côtés dans le projet qui est celui que nous menons au Maroc depuis 2021. Mais quand Mustapha m'a posé la question de savoir sous quel angle il fallait regarder les projets saillants au travers la planète, j'ai d'abord eu envie, entre deux avions, dans la nuit, de regarder le sujet sur l'angle mort des pays émergents, qui ne regardent pas le sujet de la même façon que les Occidentaux, avec leur regard cartésien sur la logique de l'accès aux ressources et de l'utilité des ressources. Et que donc, dans cette logique-là, c'est toujours les mêmes questions qui reviennent, et la question qui revient pour les pays émergents, c'est comment fait-on rencontrer cette nouvelle ressource à un marché pour être rapide sur l'accès au marché et pas être dans un processus très long, comme souvent on sait le faire en Occident, pour aller d'abord déterminer quels sont les volumes, les technologies, les techniques. On a évidemment besoin de se poser toutes ces questions. Mais on a aussi un énorme, comme l'a dit Mustapha tout à l'heure, un énorme background de 100 ans d'exploration gazière et pétrolière. Et que donc toute cette connaissance, elle nous sert à aller beaucoup plus vite et à regarder le sujet autrement. Et les pays émergents, peut-être, au lieu d'entrer par d'abord le volume, et puis pour quels besoins, et puis ensuite, quelle est la maturité finalement de tout cela, eh bien peut-être qu'ils vont regarder les choses autrement. Si on peut, voilà, next slide, please. And, cette carte est juste une illustration, mais c'est pour simplement montrer que, et elle est très très vulgarisée, mais elle montre les structures géologiques au travers de la planète, et notamment les structures cratoniques, qui sont celles en particulier qui vont nous intéresser. Et donc, quand on discute et quand on travaille avec les pays émergents, comme ça peut être notre cas, comme c'est le cas de Storengy ou d'Engie et de tous les opérateurs sur la planète, pas seulement l'exploration n'est pas forcément toujours dans les pays occidentaux, eh bien, on se rend compte que la première chose qu'ils regardent, c'est quelle est la maturité du marché. Et la maturité des marchés accessibles, le premier, parce qu'il répond à un besoin stratégique, politique, c'est celui des fertilisants. Et le Maroc ne s'est pas trompé sur le sujet depuis longtemps. Et puis, bien entendu, dans cette rencontre, c'est pour répondre à quel besoin? C'est pour répondre aux besoins de l'autosuffisance alimentaire versus la démographie galopante pour un certain nombre de continents, dont notamment l'Afrique, avec, on le sait, 2,5 milliards d'habitants en 2050. Donc c'est une croissance qui est très très importante, et donc il va falloir répondre à ces challenges-là. Et puis, donc ça veut dire que les projets par pays, en fait, vont se dimensionner, vont se sizer en fonction d'un besoin identifié et pas à l'inverse. Hein, on n'est pas dans une logique de, en tout cas pas systématiquement, il peut y avoir des mix, bien sûr, comme au Maroc d'ailleurs, des mix qui consiste à se dire une partie de la production peut partir à l'export, mais une partie de la production peut être intégrée verticalement dans le pays parce que la valeur peut rester dans le pays et donc elle est très impactante. C'est le cas dans les Congos, je dis les Congos parce que les DRC et Brazza, c'est le cas, j'ai mis quelques exemples de Guinée, Sénégal, mais c'est aussi le cas en Asie centrale, c'est le cas en Inde, dans différents États indiens. C'est le cas au Moyen-Orient et c'est le cas aussi en Asie centrale également, comme des pays comme le Kazakhstan, par exemple, je n'ai cité que celui-là, qui regarde ce sujet de cette façon-là. Next slide, please. Et donc, juste pour illustrer, et je vais faire très très vite, parce que je sais que je n'ai pas beaucoup de minutes, donc je vais faire vite. Pour faire une tonne de grains, il faut 30 kg d'engrais. Retenez bien ce chiffre. Une tonne de grains, c'est une moyenne, hein, donc du maïs, du blé, une céréale quelconque. Donc retenez ça, parce que ça permet de comprendre dans une chaîne de valeur quel va être le besoin, et donc quel est le gap qui existe entre la réalité d'aujourd'hui et et le challenge que l'on doit relever. Next slide, please. Donc j'ai pris l'exemple de la République démocratique du Congo, 100 millions d'habitants. Et dans ce pays aujourd'hui n'utilise que 10% de ses terres arables. Donc 80 millions d'hectares, au total, 8 millions utilisés. C'est très peu. Et sur ces 8 millions utilisés pour cultiver, la RDC n'utilise que je ne vous dise pas de bêtises, 1 kilo d'engrais par hectare. Juste pour vous donner une échelle, les États-Unis mettent 400 kilos par hectare pour le maïs. Ça donne le gap. Donc, Et quand on a une population qui croît, qu'on a un problème d'autosuffisance alimentaire, malgré la richesse de ce pays, eh bien, il faut sûrement se poser la question autrement, puisqu'aujourd'hui, la RDC est 100%, comme quasiment toute l'Afrique, est 100% dépendante de l'importation des engrais, des grands producteurs d'engrais dans le monde. Donc, la RDC, quand elle a regardé la problématique de l'hydrogène naturel, elle l'a regardé en se disant comment je fais pour intégrer une chaîne complète, et une chaîne complète pour arriver à ce qu'on appelle les accords d'Abuja, c'est-à-dire 20% des terres arables utilisées, ce qui n'est pas le cas aujourd'hui en Afrique, 20% des terres arables avec une quantité par hectare qui monterait à 50 kilos en moyenne. Vous voyez, rien que pour un pays comme la République démocratique du Congo, c'est passé de 1 kilo à 50 kilos. C'est un gap absolument gigantesque en termes de coûts, en termes d'infrastructures, en termes de moyens techniques. Et donc, pour cela, et je vais passer à la slide suivante, s'il vous plaît, et c'est la dernière, juste vous montrer comment l'hydrogène naturel peut être une ressource et non plus un vecteur, comme je l'ai entendu ce matin dans une autre conférence il n'y a pas très longtemps. Revoir les fiches. Comment l'hydrogène naturel peut répondre en partie, ou en tout cas peut apporter des réponses à cette problématique-là. Quand vous utilisez l'hydrogène naturel pour faire de l'ammoniac, donc du réformage de H2 pour faire de l'ammoniac, puis de l'urée, l'urée c'est un engrais naturellement, eh bien vous coupez toute la chaîne de valeur en termes de coûts, vous réduisez les capex de 20%, les opex de 20% et les feedstocks de près de 70%, 70%, pardon. Pardon, je vous parle en Suisse. Donc, on a un enjeu qui est, et pour tous ces pays-là, tous ceux que j'ai cités et plein d'autres, il y a un enjeu à regarder la chaîne de valeur par une intégration verticale locale. Peut-être pas en totalité. Peut-être qu'une partie servira à ça, une autre partie sera exportée. C'est souvent des stratégies mixtes qui sont gagnantes. Mais ça permet d'avoir, grâce au coût, comme l'expliquait tout à l'heure Olivier, grâce au coût d'hydrogène naturel qui est très très bas, grâce à la simplification de la chaîne de valeur, de la chaîne technique, de la supply chain pour fabriquer de l'ammoniac et faire de l'urée derrière, eh bien, on arrive à avoir des solutions et des projets industriels qui rencontrent leur marché, qui sont rentables et qui permettent de pouvoir garder une partie très importante de la valeur dans le pays. Voilà. Juste pour conclure, c'est finalement, on passe du XXe siècle au XXIe siècle et on voit que le XXIe siècle sera peut-être celui de l'intégration de la valeur dans les pays.
Merci Stéphane pour cette analyse pertinente. On voit bien votre background financier. C'est une analyse qui diffère un peu de l'analyse, un peu, si vous voulez, géoscientifique, a présenté Olivier ou Reda. Donc, vous donnez une richesse inestimable à ce panel pour donner cette profondeur justement dans l'analyse du marché. Mais moi, je vous remercie pour tous ces éclaircissements un peu très éclairés. Et on va passer au second round. I will switch in English because I have the recommendation from the organizers just to manage and to moderate this in English. And this we will be focused now in Morocco. Morocco, is there any natural gas, natural hydrogen? Natural gas, yes, it exists. And also natural hydrogen. Natural hydrogen, I will underline that we have taken this adventure in 2018 in ONHYM, the National Office of Hydrocarbons and Mines. And we challenged ourselves. If there is any potential, we have to take the adventure from the beginning. And as a pioneer, the office have taken all what to have be done. And with our geoscientists, but also we have been accompanied by many experts who have appeal. I just in my mind there's Gonik, which is a reference on this, but also we have been contacted by geoscientists from Solingi, and now we have done a lot of works from the beginning, from 2018, and if you allow, I will give the floor to Rida Nbedi, who will give us all what have been done from the beginning for the assessment of Morocco's natural hydrogen potential. Rida, the floor is yours.
Thank you. So before I start, I would like to just present the National Office for Hydrocarbon and Mine for those who don't know it. It's a public company which is in charge of mineral and petroleum exploration in all Morocco. It was created almost a century ago, and it is considered as a catalyzer for all the mining exploration and petroleum exploration, because it was at the origin of the discovery of almost all the operating mine in Morocco. So with this role, ONHYM continued in 2017 by switching to the exploration for renewable energy, natural renewable energy, such as geothermal and natural hydrogen. So we started from scratch. The first assessment was carried out in 2017 by combining all the geoscientific data available and trying to find out the area that had the most potential for the exploration for natural hydrogen in Morocco. So as a result of this work, we identified several target areas in Morocco that in 2019 we launched the support and international expertise to further assess these targets. Next slide, please. So with the help of international experts, as Mr. CHAIB said, we did some field works to do the follow-up, to control these targets, and most of them showed that it has great potentials for the presence of natural hydrogen reserves in the subsurface. Based on the result of in-situ measurement or laboratory analysis, or even geophysics data that has been collected in the field, and also based on infrastructure and logistics that is available in the area of this target, there has been a ranking of this target that has been performed. And from the bottom to the best one, we find the Gibat Shield, the Khmisat Basin, the Southern Coastal Basin, and in the top, it's the Coastal Meseta. Next slide, please. So, to continue, as a result of all of this, and in collaboration with the Ministry of Energy Transition, some exclusive exploration area have been allowed to ONHYM, where it has signed partnerships with 3 partners to date. The first one was HYNAT in the southern provinces. Then 2 on the coastal, Meseta coastal area, one with Storengy in the Ben Sliman Barshid Basin, and the second one with UM6P in the Khamisses Basin. Next, please. So, in addition to this area where we're working with our partner to develop, ONHYM is still deploying its effort to look for additional target to develop. And here, for example, in this slide, an example of the works that has been performed in the area of Ain Bni Mtahar, Chandrara, that shows the presence of similar structure and similar fairy circles to the one in the coastal Meseta or the southern provinces. Until now, we have received encouraging results, and we still deploying our effort in other areas to confirm the potential for natural hydrogen in them. Thank you.
Thank you, Rida. Very interesting and very important. So, all the discoveries done by ONHYM so far to identify these fairy circles with evidence of hydrogen seep, it's really good results, and we hope that we will continue. And we are continuing in a way, mainly with our partners. HYNAT was the first partner we signed in 2021, and now I'll give the floor to our two partners present in this panel. HYNAT first, our partner in the southern provinces. Stéphane, it's your floor, and if you want to switch in French, no problem, please do, as you feel it's comfortable.
Very briefly, just to give you focus on the project in the south of Morocco. Next slide, please. Voilà. Nous avons, depuis 2021, fait une série de travaux avec l'ONHYM sur des zones préidentifiées. Nous les avons classifiées en 3 zones de priorité. Et ces 3 zones de priorité sont adressées pour mener une seconde phase de travaux qui sont des travaux de géophysique, de sismique. Et la zone de priorité 1, qui a été celle que nous avons retenue donc en priorité, comme son nom l'indique, pour plusieurs raisons. D'abord parce que les résultats étaient particulièrement attrayants, parce que les travaux qui ont été menés étaient suffisamment aboutis pour pouvoir passer à l'étape suivante. Et puis, l'autre raison qui est très pratique, c'est que nous sommes dans une zone qui est en toute proximité de Dakhla, et donc pour des questions qui sont liées à l'organisation industrielle, à la logistique future, eh bien, ça faisait plus de sens de s'attacher d'abord à cette zone-là. Donc nous avons retenu cette zone-là en zone de priorité 1. Les 2 autres zones sont également en traitement, mais avec des process parallèles. Next slide. Voilà, pour donner l'essentiel des travaux sur cette zone de priorité 1, la phase de géophysique, alors elle n'est jamais terminée parce qu'on fera d'autres travaux, d'autres acquisitions, évidemment, même de surface d'ailleurs, et en monitoring sur la zone, mais nous avons pris la décision avec l'ONHYM en mai dernier de lancer la phase de forage pour mener une série de forage tests sur un endroit particulier qui a retenu toute notre attention en termes de résultats, c'est-à-dire en termes de structures géologiques à très faible profondeur, des structures géologiques d'accumulation et de réservoirs qui sont particulièrement intéressants, puisque on a des structures d'accumulation qui sont potentiellement de très grande taille. Je dis tout ça potentiellement parce que, là encore, beaucoup de prudence dans les annonces, donc pas d'annonce, pour être clair, pas d'annonce. Je dis ça parce que je sais qu'Olivier aussi n'est pas un fervent des annonces. Moi, je n'aime pas les annonces. Il y a beaucoup de gens qui annoncent des trucs extraordinaires. Nous, on ne veut pas faire d'annonces tant qu'on n'a pas ouvert un robinet, en gros, pour le dire simplement. C'est-à-dire tant qu'on n'a pas pu valider les pressions, les volumes, les qualités, les concentrations définitives, et puis le fonctionnement du puits. Donc c'est en cours. La campagne de forage est en préparation, elle est en cours pour faire probablement 3 forages tests sur la zone, puisque c'est à ça que l'on s'est arrêté. 3 forages tests sur la zone, avec derrière entre 8 à 12 mois d'équipement, si on valide ces forages, pour les équiper en moyens de production, et donc être en capacité, nous l'espérons, avec les off-takers, être en capacité de pouvoir ouvrir un premier puits dans le second semestre 2025. Merci.
Merci Stéphane pour ces éclaircissements, et aussi l'ONHYM, on n'est pas dans les faits, c'est notre ligne de conduite aussi pour les annonces, on ne fait pas trop d'annonces pour en faire, donc ça nous sommes d'accord, we are in the good position, and we hope all the best for our projects, for our common projects, because it's if we will succeed, it's a team, it's not, and we hope all the success to this project, the first project, the first jailings we will normally do in this province. And now, if you allow, I will give the floor to Olivier just for the partnership. We just signed just in last summer, in last July, and Olivier, we have started working in the framework of an NDA before, and we officially signed last July for our first agreement, and we will start to work. And please, Olivier, if
yes, and we are very happy to start this project that we are maturing for a long time now. So you can see where it is located on this map. So it's the coastal meseta, it's the geological province, and to really mainly focus on the Bereshid basin that you can see south of Casablanca. And we will do that in partnership with ONHYM to explore this area. If you can go on the next slide. So this is a zoom on the same, I would say, map that you saw previously. And you can see all the dark blue points that are located on the map, which are some, I would say, elliptic structures where we speak about that in the beginning. Natural hydrogen tend to escape or to be emitted through those elliptical structures. And ONHYM made, I would say, a campaign to survey all these fairy circle, that we call it fairy circle or elliptic structures, and found very high content of natural hydrogen in those elliptic structures. So saying that there is a lot of natural hydrogen emitted in this basin. So the purpose now is to find an accumulation. So we will look at more to the south, to Casablanca. You can see on this map where you have the bluish color, the location of the basin where we think we could have some accumulation trap in the basin. And in the next slide, we will do that by doing some exploration work. First, by assessing on the long term this natural hydrogen emission on the fairy circle with the sensor that we develop internally. So that's the Paris sensor that you have on the right low corner. We will measure during several months the emission on the basin, on some area, and perhaps measure also the flux that is emitted at surface to give an idea of the prospectivity of the basin and the amount generated within the basin. We will do also some passive seismic to get, I would say, some clue regarding the structuration of the basin. That there is not a lot of data in that area that was not explored for mining, not really explored also for oil and gas. So we need to acquire some geophysical information to have some kind of echography of the subsurface, which can allow us to define some trap at the end. And with this passive seismic, we may also be able to track some movement of this natural hydrogen within the subsurface, and we will correlate that with the Paris sensor that we have deployed in the same area, so we can then correlate at the same times possible emission at surface and also observation in the subsurface. And the idea, after, I would say, a year of this exploration, is to define possible trap, and we will go further with acquisition of data, continuous with the seismic, and if all the indicators are positive, to drill a well in the location that we have defined. So that's the idea. And in the next slide, I think NG and StorNG have, I would say, interesting knowledge on that topics. First, by the techniques and tools that we developed. So Paris sensor are, I would say, almost unique in the market to measure that on the long term, this emission, which are not continuous, but by pulse. So it's really key to capture those emissions with also the passive seismic that we have deployed for many years on our storage. We have also some expertise in equipment, on drilling, on surface equipment with hydrogen from our experience of our underground storage of hydrogen in salt cavern in France. So we may extend that to this exploration. And if we need some pipeline, if the client is a little bit far, In Casablanca, I think if we found some hydrogen, I think that there are many clients, and one particularly which is obvious and will use this hydrogen, but in case there is some need of infrastructure, we have also a division that can also build some pipeline in order to conduct this natural hydrogen to the client, and we have also a special division to build contract of take with the clients in order that they can secure their sourcing of hydrogen.
Okay, Olivier, we are very lucky to have identified these structures and this potential of hydrogen just near this economic region, which is Casablanca, and you know all the ecosystem is there, and the infrastructure, and we believe on the expertise of Storengy and the capabilities also of NG, their presence here in Morocco, and we hope all the best for these projects as well as the projects in the south. So we will be in continuous progress, and this is our goal as ONHYM, as a state-owned company, as a public company, and we are supported also by all the expertise that we can bring from our partners, and we thank them for all of this. It's the end of this panel, but I will let the floor to some questions in the audience. If you have some questions, please. Yes, sir.
Thank you. Good morning. My name is Miko Blujon-Mered. I'm a researcher on hydrogen, natural hydrogen, but from the geopolitics and market development side. I'm training on this at UMC-SPE on the Rabat campus. And my question to you guys is, how do you see the competitive landscape beyond Morocco, here in Africa, and beyond DRC, of course, and also globally? Of course, there's a lot of prospects everywhere, but how do you see Morocco faring in terms of competitive advantage regarding natural hydrogen compared to all the other countries who are actually making a lot of announcements? Thank you.
Thank you, sir. Olivier?
Yeah, I think that Morocco with ONHYM is offering, I would say, some acreage to explore this natural hydrogen. So I think it's a first step to highlight the potential of Morocco, and I think after, for sure, they need some regulation later on to be put in place, and it will attract perhaps more and more, I would say, explorationists and exploration company to explore for Morocco. But at least if with ONHYM, I would say the potential can be highlighted, it's really the first step. And for sure, I would say that there is some competition. We can see that in the US, there is a lot of companies starting to drill. But I think, Morocco as a role, as a key, I would say, element also in the subsurface to also be competitive. I think once the potential is confirmed, there will be a lot of, I would say, company coming to explore also in Morocco, I think.
Yes, of course, Olivier. Stéphane, if you have something to add, please.
Non, juste pour compléter, en fait, le Maroc a un grand historique, un énorme savoir-faire, et pour toute son histoire. Le Maroc a l'ADN, la DNA d'être dans l'anticipation des grands sujets de transition. Et c'est bien sûr le solaire, mais ce n'est pas seulement le solaire. Donc il y a une culture qui est extrêmement favorable. Et puis il y a évidemment une troisième condition qui est majeure, c'est qu'il y a des conditions géologiques qui sont particulièrement, on va dire, qui réunissent, on peut dire, la courbe de probabilité qui permet de pouvoir se dire qu'on va pouvoir trouver ça. Donc oui, et quand l'ONHYM a engagé cette réflexion en 2017, on peut dire dans les tout premiers, hein, parce que c'était vraiment dans les tout premiers, à l'exception du Mali, et puis de quelques accidents à gauche et à droite, ou de travaux universitaires qui ont été menés au Brésil ou ailleurs. L'ONHYM a donné un start pour engager cette réflexion. Et donc nous, on est évidemment très heureux d'être partenaire de l'Office.
Just I wanted to underline what said by Aver, Stéphane. We are pioneers. Morocco is pioneer in many domains. And precisely in this, for natural hydrogen, we have started in 2016 and concretized in 2017, 2018. But anyway, we are in, and we have the potential to be just a hub, even for many African countries. And we have a good relationship with many countries in Africa, and we are in this trend. Thank you.
If I may add, in addition to being a pioneer in exploration between the 10% more explored countries for natural hydrogen, I think that in terms of competitiveness, as you said, Morocco has two key points that he can rely on. It's the first one is that we have a local market. We have a local need for ammonia. So you have a local need, and the second one is the geographical position of Morocco. If there is export, you're in one of the best places to be. Thank you.
Other question? Yes, sir.
Hi, my name is Usama. I'm from Innovex. My question is about the potential of the market more globally. And we starting to hear a lot about natural hydrogen these last few years with the investment that our dear panelists highlighted. So do you think, or when do you think that natural hydrogen will reach maturity and will have projects announced at large scale like we're hearing today in green hydrogen?
I think we're still in the beginning of the exploration. The only one of site production now is a small scale one, producing like less than 50 tons of hydrogen per year. The well that has been drilled in the United States, the results are still confidential, and we don't have any idea about the potential and the research there. But I think that the next decade will bring us the answer to this question. Many startups are joining, many majors are joining. The majors, I think that the majors can make the difference in this race.
I agree, and I think that in the coming months, and it started already in the US and also in South Australia states, some wells are drilled, especially to find some natural hydrogen and not by accident. So we think that in the coming months, we will see a lot of wells be drilled by those small companies that are raising funds, and we will see really the potential of this natural hydrogen in the coming, I would say, 2 or 3 years. If it is a real game changer, or it is, I would say, more anecdotal. The indication seems that it's widespread, so maybe it can really help the hydrogen economy. We will not replace all the green hydrogen. We will need the green hydrogen. We will need the white hydrogen as well. We will need all kind of hydrogen to develop the hydrogen economy. But perhaps it may contribute in the coming, I would say, 2 or 3 years to see if it can really contribute significantly.
I hope that you have the answer to your question, but on my point of view, there is a rush for natural hydrogen in the world. And we are expecting now the first really industrial project to be built, as said by Olivier or Reda, lots of drilling, but we don't have any evident resources as volume and feasibility. But what we hope is this natural hydrogen, anyway, we will join the value chain of the hydrogen, even the green hydrogen in here in Morocco or. Okay, maybe we have lots of questions here. Yeah, just firstly there, and we will get
Thank you.
The next.
Thank you very much. I'll try and keep it very short. The question I have, actually multiple questions, maybe I'll have a chat with you afterwards, after this event, but the one that I wanted to try to understand is a bit more on the processing of the hydrogen once it is producing. So how much cleansing does it require? How much of the processing is required on the hydrogen once you've taken it to the wellhead? And try to understand, like in the natural gas state, you may have sulfur that's attached to the natural gas, methane, ethane, whatever it is. So, is there issues with what you're seeing right now that may need some cleaning of this hydrogen once it is produced? That's one question. I also, my understanding of this discussion as well, to clarify, is that there is no commercial production of natural hydrogen as of today. But there was a story we saw in Mali that was a successful story of production that was coming there. What's happening with those volumes in Mali at this point? I mean, my understanding was that it was potentially they're burning that hydrogen to produce power. So just more on the processing aspect, and also what's the latest on the Mali story? Thank you.
Stéphane or Olivier?
I can start, yes. Regarding the gas composition, so in Mali, it's 97% of natural hydrogen, 1% of nitrogen, 1% of methane. So usually those two gases, so nitrogen and I would say abiotic methane, which is the reaction between the CO2 and the natural hydrogen, which form this abiotic methane that you can find together with natural hydrogen, can, I would say, be part of the, I would say, the gas mixtures that we can find in the subsurface and that we can observe also in other wells where we have some gas analysis. So the percentage can vary. We will really chase when, I would say, natural hydrogen is up to 70 to 80%. So we will look at area where natural hydrogen will be really the main component of this association. And then, for sure, when we will produce, we will need some gas processing anyway to separate from the nitrogen and also the methane, which could be used locally to run the process and all the equipments on site. Then regarding Mali, I don't know, I think that there are 25 wells that have been drilled, to my knowledge, and they're still waiting, I would say, investors and market in order to go further. Accumulation has been proven. The 25 well seems to have, I would say, found some natural hydrogen. Then just need, I would say, investors and market.
Thank you, Olivier. Maybe we will take the two last questions, maybe in this part. Yes, please.
Well, it's a very simple question. I have a background in transport, and I already worked with Acus on hydrogen in transport before. And my question would be about the usage of this natural hydrogen for other application like transport or, for example, clean cooking, because it's the new topic in Africa. And what about, and you talked about the fertilizer, but isn't it also a good idea to use it for the methanol production? It is less dangerous to transport and also way cheaper. And what could be the future opportunities for hydrogen as a source of methanol for African countries? Thank you.
Merci, c'est une excellente question, mais ça illustre absolument le regard, le double regard qu'on a quand les occidentaux et les émergents. C'est-à-dire que la question du transport, c'est une question de timing. C'est-à-dire que le marché n'est pas encore là. C'est pas qu'il a du mal à décoller, c'est qu'il y a une question de temps pour pour switcher d'un modèle industriel à un autre modèle industriel. Et que les capex sont tels qu'il faut un certain temps. Voilà. Et c'est vrai d'ailleurs également pour la production de l'hydrogène. Passer de l'hydrogène gris à l'hydrogène vert, il y a eu beaucoup de capex pour l'hydrogène gris. Il faut passer à l'hydrogène vert, il faut beaucoup de capex aussi. Et puis dans l'angle mort, il y a un truc qui s'appelle l'hydrogène naturel, qui est un peu dans l'angle mort et qui, c'est toujours la même molécule, hein, il n'y a aucune différence naturellement, mais en revanche, on doit être capable, compte tenu de ce que l'on sait aujourd'hui, des expériences passées et puis de ce que l'on voit en ce moment sur le terrain dans différents endroits, d'avoir effectivement un coût ex-works, donc sortie de puits, qui va osciller entre, alors, Olivier donnait des chiffres tout à l'heure, entre 50 centimes annoncés au Mali, de dollars, 50 cents de dollars, à peut-être 1,5. La question du coût, c'est la question de la localisation, de la profondeur, de l'infrastructure, et puis des contraintes de stockage et de transport. Parce qu'évidemment, au Mali, c'est un peu moins simple qu'à Darla. Probablement. Probablement. J'ai de beaucoup de prudence dans toutes les réponses. Voilà. Donc oui, le transport fait partie de la roadmap. Ça va sûrement adresser d'abord le transport lourd et puis ça peut descendre. Mais en même temps, on voit des expériences HYP en France, à Paris, et puis dans d'autres villes maintenant, je crois aussi. On voit des expériences qui se passent, mais on voit il y a un certain temps pour que cette chaîne de valeur, cette chaîne industrielle se mette en œuvre. Là encore, l'hydrogène naturel permet d'apporter dans ce timing long, avec des capex très élevés, l'hydrogène naturel peut apporter une réponse en avance de phase dans ce process de transition énergétique vers l'hydrogène pour répondre à des problématiques d'ici à 2030. Et donc c'est pour ça qu'on parle des émergents qui regardent, eux, des marchés sur des besoins qui sont immédiats, et notamment les fertilisants. Il y a aussi la production d'électricité, mais il y a d'abord les fertilisants. Voilà.
Il y a les Coréens, on a assisté à des présentations ce matin où j'y suis hier sur les voitures à hydrogène. Donc ça donne beaucoup de sens avec ce que dit Stéphane. Thank you. Maybe it's the last question. I guess we are just on time or just out of time. I don't know about this. But as we are here, I just want to reiterate my thanks to our panelists, our experts. Thank you, Stéphane. Thank you, Olivier. Thank you, Reda, for your exciting. And I hope that next year, in the next summit, we will have the time for one session for natural hydrogen. I guess regarding the results we will get, and we are very optimistic about all what we are doing. And the guys from UMCSP are also present with us. They are partners of ONHYM. We hope that we will get more results, exciting results for next year, and all the best for this new sector dedicated to natural hydrogen. Thank you, everyone.